Hello everyone, a very good morning all of you, and a very warm welcome to you all to this wonderful practice session for thermodynamics and its application for your BARC 2024 examination. So I hope you guys are doing well and doing your preparation for the BARC 2024 with your full dedication, hard work and enthusiasm. So to improve your preparation, to improve your confidence, we are here with the BARC atomic series, and today's session will be all about the beautiful, wonderful handpicked questions from the thermodynamics and its application. Please guys do join me fast, and those who are here respond me through the comment section if my audio and visual quality are fine, so that we can start this practice session. Keep your notebook, pen and calculator. Try to solve the questions on your own, and in case of any doubt you just let me know through the comment section. क्या मेरी आवाज आ रही है आप लोगों को? Those who are here respond me through the comment section. Can you guys hear me? Namaskar, Adab, Suprabhat, good morning, Sat Sri Akal, Assalam Walaikum, Wanakam. Please get yourself settled down fast and do let me know if audio and visual quality are fine. This is my quick introduction for those who are attending my session for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I graduated in 2006. I have also cleared engineering services examination in 2009. I had worked in Steel Authority of India Limited for more than 2 years, and also I have worked in a private consulting firm for a couple of years. So my total work experience, industry experience is more than 4 years, and the rest of my experience is into teaching. I have been into teaching from the last 10 plus years for various examinations like GATE, engineering services and other PSUs. I am very much comfortable in these many subjects, these many fundamental subjects of mechanical engineering, fluid mechanics, heat transfer, thermal and industrial. So there are a lot of students who are part of my Telegram channel who are preparing for GATE or ESE or other PSUs. So please do join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and the link is also there. I am not able to see your comments. Nobody is writing. Why? Please do write in the comment section, those who are here. Am I audible and visible to all of you or not? आवाज आ रही मेरी? Is my audio video clear? Please do write Y in the comment section if it is yes, and do write N in the comment section if it is no. Everyone, the more you communicate, the more comfortable you become with the subject, with the concept, with your confidence. My Telegram channel is Mechanical by Chandrasekhar, right? Or this is the link. Once you become part of my Telegram channel, you will be getting so many benefits. We will resolve your doubts through the Telegram channel, important information, important questions, important notes, PDFs, everything will be shared through the Telegram channel only. Okay, so one more information before we start. Hi Sundaram, good morning, welcome, how are you? So keep your pen, notebook and calculator. There are around 15 questions in total. Some questions are from the basic thermodynamics and some of the questions are from the applied thermodynamics. So, and each question will give you an understanding or the revision of the concept for your BARC 2024. So there is an important workshop today at 7:30 p.m. I hope you guys have registered for the workshop. If not yet, do not forget to register yourself. The link is already there in the description box of this session. And the workshop is completely free, and it is about how to prepare for your GATE 2025 along with your job, work, along with the college. All right. So the session will be taken by Richa ma'am. She is MTech from NIT Raipur, having more than 5 years of teaching experience in GATE and ESC. So let us start with question number 1. Everybody read the following question carefully. There is an ideal gas which is undergoing expansion according to this law. PV to the power 0.5 is constant. When there is an expansion of this ideal gas, the temperature of the gas will not change. The temperature of the gas will increase, will decrease, or it might change depending on the initial condition or initial condition of the system. All right. Yes. Can you solve it? Can you solve it? Yes, I want everyone to keep responding your answer through the comment section. I am waiting for your answers. Because it is an ideal gas, for an ideal gas, one more relationship we know. That is ideal gas equation. PV is equal to mRT. Or we can say P into V is directly proportional to temperature. Or we can say, because in this expression, our objective is to develop a relation between temperature and volume, isn't it? The objective is to develop a relation between temperature and volume. Because the expansion means volume is increasing. Due to increase in volume, what will happen to the temperature? That is the question. So from here, can we write, just hold on. From here, can we write P is proportional to T by V? Isn't it? Pressure is proportional to T by V. Put it here. So pressure is T by V into V to the power 0.5 is constant. Or can we say T upon V to the power 0.5 is constant? Or can we say T is proportional to V to the power 0.5? Yes or no? This is the relationship. So the relationship is very much similar to this. इस रिलेशनशिप को यहां से कंपेयर कर सकते हैं. फॉर y is proportional to x to the power a. If y is proportional to x to the power a, this is y, this is y, this is x, and this power is a. For y is proportional to x to the power a, as x increases, as the value of x increases, y will increase if a is positive. Y will decrease if a is, y will increase if a is greater than 1. Y will decrease if a lies between 0 and 1. A lies between 0 and 1. If a lies between 0 and y. And y will remain constant, or y will be equal to constant if a is equal to 1. If a is equal to 1, by increasing x, if a is equal to 1, what will happen? If a is this true or not? It should have been like this. By increasing x, y will increase if A is positive. My mistake. By increasing x, y will decrease if A is negative. Yes, that is true. A is negative. And if A is equal to 0, then y will be constant. So this is how the relation will be, isn't it? Yes, ancient. Correct. So if you see A is positive. So by increasing volume, what will happen to the temperature? By increasing the volume, what is going to happen to the temperature? It is positive. A is positive. A is 0.5, which is positive. So by increasing the volume, by expansion, there is an increase in temperature as well, isn't it? Do you agree or not? Sundaram, it should be B, na? It should be B. If there is a relation y is proportional to x to the power a, so by increasing the value of x, y will increase only if a is positive, y will decrease if a is negative, and y will remain constant if a is equal to 0. So that is how we can develop a relation for this. I hope this is clear, everyone. If anybody is having any doubt, do let me know. B for Bombay will be the correct answer for this one. The next question on your screen. Question number 2. Air, the adiabatic index or specific heat ratio gamma is 1.4, is compressed ideally from an initial state of 1 bar. It means initial state is 1, P1 is equal to 1 bar and T1 is equal to 300 Kelvin to a final temperature T2 is equal to 600 Kelvin. What will be the value of P2? That is the question. Very simple question. Compression ideally means it is reversible adiabatic compression. Ideal compression is reversible adiabatic compression. Or we can call it as isentropic compression. The compression will be reversible adiabatic or isentropic. Ideal compression means isentropic compression or reversible adiabatic compression. For the reversible adiabatic process, PV to the power gamma is constant. Or we can say from here, because it is an ideal gas, air is an ideal gas. Air will be treated as an ideal gas. So PV is equal to MRT also we can write. So from here T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma is equal to V1 by V2 to the power gamma minus 1. This is what the relation is for an reversible adiabatic process from 1 to 2. As the temperature increases, pressure will also increases, volume will decrease because gamma is greater than 0. Gamma is positive. Gamma is actually greater than 1. Gamma is greater than 1. That is why this. As the temperature decreases, pressure will decrease or volume will increase because the value of gamma is greater than 1. But here if you see the value of gamma is less than 1. That is why by increasing the temperature temperature will also increase. That is why in the previous question, the answer was different. So from this relation, we can easily write the expression P2 by P1 is equal to T2 by T1 to the power gamma upon gamma minus 1. The objective is to find out the value of P2. P2 is equal to what is P1? P1 is 1 bar into T2 by T1, 600 by 300 to the power gamma. Gamma is 1.4 divided by 1.4 minus 1, that is 0.4. That much will be the answer in bar. What will be the answer for question number 2? Can you do the calculation? 2 to the power 7 by 2 or 3.5? 2 to the power 3.5. The answer will be 2 to the power 3.5, isn't it? 2 to the power 3.5 will give you the answer. It will be 11.3. The answer to this question will be 11.3. I hope this is clear to every one of you. Question number 2. Let us move to the next one. Question number 3. Yes, Sundaram. Well done. Good. An ideal gas, the adiabatic index is 1.39 this time, flows in a pipeline at 450 degrees Celsius. There is a pipeline and there is an ideal gas is flowing in the pipeline. So the pressure in the pipeline is 20 bar is the pressure. 20 bar is the pressure in the pipeline. And the temperature in the pipeline is 450 degrees Celsius. A rigid insulated and initially evacuated tank. There is a tank. It is rigid, thermally insulated and initially evacuated, initially empty tank or a vessel is connected to the pipeline through a valve. This is connected to the pipeline through a valve like this. The valve is now opened. This is the valve. It is now opened and the gas is allowed to fill the empty vessel. The gas enters into the empty vessel. When the valve opens, the gas enters into the tank or the vessel. And the gas is allowed to fill the empty vessel. The final temperature of the gas in the vessel is the final temperature of the gas. So T2 will be how much? That is the question. I for inlet or entry, the fluid or the gas which is entering, this is an ideal gas which is entering into the tank or the vessel. E is the exit, let us say, or outlet. When the gas leaves the tank, this is entry, this is exit. 1 is for inlet condition of the gas in the tank and 2 is the final condition of the gas in the tank. नहीं एंसेंट हेवन, यहां आपको थोड़ा सा कंफ्यूजन है. देर आर टू रिलेशंस एक्चुअली. वन इज y इज इक्वल टू x टू द पावर a and y is equal to a to the power x. Just hold on, give me a moment. Am I audible and visible? Am I properly audible and visible to all of you? आवाज आ रही मेरी? All right. Yes, so I was telling you that there are two relations. One is a to the power x and another is x to the power a. Look, in these two relationships, so as x increases, here y will increase if a is positive, y will decrease if a will be negative. If y is a to the power x, then x will, by increasing the value of x, y will increase if a is greater than 1, and if a lies between 0 and 1, y will decrease, and y will be equal to constant if a is equal to 1. This is one relation. The another is, as x increases here, y will increase if a is positive, y will decrease if a is negative, and y will be constant if a is equal to 0. Are you getting it? So our expression was this: y is proportional to x to the power a. This was our relationship. Because a is positive, that is why by increasing V, temperature will also increase. Do you understand it, ancient? These are the two different relations, and these are the condition for these relationship. These are the mathematical relationship. One is y is proportional to x to the power a, another is y is proportional to a to the power x, right? So if a is positive, y will increase; if a is negative, y will decrease, and if a is 0, then y will be equal to constant. Here, if a is greater than 1, then y will increase. If a lies between 0 and 1, then y will decrease. If a is equal to 1, then y will be constant. पर ये देखिए ना, which is greater, 2 to the power 0.5 or 2.1 to the power 0.5, which is greater? Which will be more? Either 2 की power 0.5 or 2.1 to the power 0.5, which is greater? Which will be greater? Isn't 2.1 to the power 0.5 is greater? 2.1 to the power 0.5 is greater than 2 to the power 0.5. Yes or no? Then that is what we are saying. If you increase x, then y will also increase if a is positive. Right? Okay, so let us move to the next one. This is the question we were talking about. I is inlet, E is exit, 1 is the initial condition of the system, 2 is the final condition of the system. So we need to find out the value of T2. If you know the direct result, T2 is equal to gamma times of Ti. That is how you can directly solve it. So what is gamma? Gamma is 1.39 into what is Ti? 450 degrees Celsius. 450 plus 273 Kelvin. So the value of T2 will be equal to how much Kelvin it is? 450 plus 273. into 1.39, that is 1004.97 Kelvin. But if we want to convert it into degree Celsius, subtract 273, it will be 731.97 degree Celsius. Degree Celsius plus 273 is equal to Kelvin. That is the relation, right? So the correct answer is option D, 732. But how we are getting this relation, that is important. The question is from the unsteady state flow. For the unsteady flow condition, the question is from the unsteady flow. It is the unsteady flow process. If we apply mass conservation, one is if we apply mass equation or mass conservation. According to mass conservation, mass flow rate entering M in minus M out is equal to change in mass in the control volume. That is the mass conservation. Mass entering minus mass leaving is change in mass. So per unit time, if we write per unit time, then mass flow rate entering into the system or into the vessel minus mass flow rate leaving from the vessel is equal to change in mass, that is m dot 2 minus m dot 1 in the control volume. That is our expression. Now if the system is E for exit, there is no exit because there is no exit from the tank. This is our system or this is our control volume. The tank, the gas inside the tank is our control volume. So there is no exit from the tank. So this will be 0 and the tank is initially evacuated. It means inlet mass is equal to 0. So we can say m dot I is equal to m dot 2. That is one relation. Now if we apply the energy equation, if we write the energy equation for the control volume, and according to energy equation, energy entering minus energy leaving is equal to change in energy in the control volume. So energy entering is m dot I HI plus q dot minus m dot E HE mass flow rate into specific enthalpy minus W dot is equal to U2 minus U1 in control volume if change in potential energy is equal to change in kinetic energy is assumed to be 0. If there is no change in potential energy, if there is no change in kinetic energy. So look, because m dot E is equal to 0, this will be 0 and the system is thermally insulated. It means there is no heat transfer and there is no work done because it is a rigid tank means change in volume will be 0. So work will also be 0. So it will give rise to m dot I into HI is equal to, we can write m2 U2 specific internal energy minus m1 U1 in the control volume. And because the system was initially insulated, so this will be 0. So our expression will be m dot I HI is equal to m dot 2 into U2 and H can be written as, enthalpy can be written as enthalpy. So m dot I HI is equal to m dot 2 into U2 or we can say m dot I. So m dot I and m dot 2 will also be getting cancelled out because m dot I is equal to m dot 2 from the mass conservation. So HI is equal to U2. That is the final expression. Specific enthalpy at inlet will be equal to specific internal energy of state 2. So HI can be written as CPTI is equal to U2 can be written as CVT2. So from here we can find out T2 is equal to Cp by Cv into Ti and Cp by Cv is equal to gamma times of Ti. That is how we get this relation. I have already solved the question, but how to develop, because sometimes there might be given as some work done, there might be given as some heat transfer. So the question can be twisted by giving, if the system is not insulated, then there will be some heat transfer also. If the system is not rigid, then there will be some mass transfer also. Then there will be some work done also. And the system may not be initially evacuated. There might be some exit from the control volume. So accordingly, we can modify the expression. What you need to understand is the mass conservation equation and the energy conservation equation for the control volume for the unsteady flow process. All right. So let us move to the next one. If anybody is having any doubt, please do let me know. And do not forget to like and share this session so it reaches to all the other students who are sincerely preparing for BARC 2024. And if you are one of those who are preparing for GATE 2025, we are running a series called Ground Zero, where we explain the constant from the basic to the advanced level in such a manner that your concept becomes more clear and you are in a position to solve even the tough numericals. So the series is running on our Byjus app. If you have not installed it yet, please do install our Byjus exam prep app through the Google Play Store, or you can find the bit.ly link in the description box as well. All right. Next linked answer question. Question number 4 and 5. Try to solve this one. An insulated vertical cylinder. It is insulated. Thermally insulated. Insulated means thermally insulated. There is a difference between insulated and isolated. Isolated is not equal to insulated. Insulated means Q is equal to 0. Isolated means Q is equal to, or energy transfer is equal to 0. There is no energy transfer and there is no mass transfer. Isolated, there is neither mass transfer nor energy transfer. Insulated means Q is equal to 0. Mass transfer can take place, work transfer can take place. Right? Now an insulated vertical cylinder encloses 0.1 kg of argon. That is the mass of the argon, 0.1 kg. With the help of a frictionless non-conducting piston. Piston is also non-conducting. It means there is no heat transfer through the piston surface as well. It is frictionless. There is no energy loss to the surrounding due to friction. As shown in figure, the mass of the piston is 5 kg. The mass of the piston is 5 kg and it initially rests on the bottom of the cylinder. Initially the piston is here. Initially the piston is resting at the bottom of the cylinder. The cylinder is connected to the nitrogen tank. There is a nitrogen tank which is at 100 bar through a pipeline which is fitted with a valve. The valve is opened and the nitrogen is slowly admitted into the cylinder. As soon as the valve is opened, then the nitrogen enters into the cylinder. It will exert a force on the piston. During this operation, the piston is lifted through a height of 10 cm. This height is 10 cm. The piston is lifted through a height of 10 cm by the nitrogen gas. The nitrogen will exert a force, and due to the force exerted on the nitrogen, there will be movement of the piston, right? The initial pressure and temperature of the argon gas are 100 kilopascal, P1 and T1 300 Kelvin respectively. The final temperature T2 is 320 Kelvin. For argon, specific heat at constant pressure is 520 and specific heat at constant volume is 312. Now the question starts. Have you understood it? As soon as the valve is opened, the nitrogen enters into the tank or into the cylinder, and it will exert a force on the piston, and the piston will be lifted by 10 centimeters. There is a compression of argon. There will be a compression of argon due to piston movement in upward direction. Now, what will be the force, what will be the work done by the argon in kilojoule during this process? The force exerted, the work done by the argon gas. Will there be any work done by the argon? The work will be done by the nitrogen on the argon. The work done by the argon will not be there, but the work is done by the nitrogen on the argon gas, because the piston is getting lifted by 10 centimeter. Do you agree? So the work done by the argon is negative. Yes or no? So positive value cannot be correct. Work done on the system is negative. Work done by the system is positive. The work is done on the argon. On the argon gas. So that is why it will be negative. Work done will be negative. So A and B cannot be correct. And how much will be the work done? Because the process is reversible adiabatic. Because the process is reversible adiabatic. Because the piston is frictionless. The piston is frictionless, non-conducting, insulated. So it means the process is reversible adiabatic process from 1 to 2. And the work done will be equal to, between 1 to 2, it will be P1 V1 minus P2 V2 upon gamma minus 1. Isn't it? The process undergone by the argon gas is from 1 to 2. There is no heat transfer, there is no mass transfer, and there is no energy loss. Or we can write, because argon can be treated as an ideal gas, we can write it as Mr T1 minus T2 upon gamma minus 1. What is the mass of the argon? R can be written as R bar by M, or R is equal to, now R will be equal to, if we find out R, Cp minus Cv. So R will be equal to W1 to 2 will be equal to mass of the argon is 0.1 into R is equal to Cp minus Cv, 520 minus 312. Mr T1 minus T2. T1 is 300, T2 is 320. Divide by gamma is equal to Cp by Cv, 520 by 312 minus 1. That will give you the answer in joule. That will give you the answer in joule. And in kilojoule, how much it will be? Can you solve it? R is equal to Cp minus Cv and gamma is equal to Cp by Cv. Cp minus Cv is equal to R and Cp by Cv is equal to gamma. What is the answer? Are you getting option C or not? Everybody please give it a try and do let me know if you are getting option C. If you put all the parameter in their SI unit, you will get the final answer in its SI unit. C will be the correct answer. You will get a negative value. Definitely you will get a negative value because the work is done on the argon, not by the argon. The work is done on the system, which is taken as negative. Work is done by the system will be taken as positive. The next part, the work done by the nitrogen. Yes, the work will be done by the nitrogen in kilojoule during the processes. So because work is done, if the nitrogen is our system, it will be work done by the system and work done by the system is positive. So C and D cannot be correct for question number 5. So what is the work done by the nitrogen? that is work done on argon plus work done on the piston, because the piston is also lifted. So the work done, the total work done by the nitrogen is work done on the argon. How much is the work done on the argon? That is equal to 0.624 plus the weight of the piston is acting in downward direction and it is lifted in upward direction. So work done by the argon nitrogen will be equal to M into G into H, mass of the piston into G into H. So put the value 0.624, it will be kilojoule, plus what is the mass of the piston? Mass of the piston is given as 5 kg. 5 into 10, let me take it as 10 into H. H is 10 centimeter. That is equal to 0.1 meter. If you put all the parameter in the SI unit, then it will give you the joule, and in kilojoule you should divide by 1000. So 0.624 plus how much is that? Five into 10 to the power minus 3, 0.005, isn't it? So it will be 0.629 kilojoule. 0.629 kilojoule will be the answer. 0.629 kilojoule. B will be the answer. Next question, give it a try. Yes, question number 6. We are almost halfway. 1 kg of methane is enclosed in a cylinder having volume. The mass of the methane is 1 kg and the volume of the methane is 6.4 liters and is maintained at a temperature of 13 degrees Celsius and a pressure of 18.56 megapascal. The molecular weight or molar mass of the methane is 16 kilogram per kilomole. For methane, critical pressure is 4.64 megapascal and critical temperature is this. Universal gas constant is 0.314 kilojoule per kilomole Kelvin or joule per mole Kelvin. What will be the compressibility factor? What do you understand by the compressibility factor? It gives the information about the deviation from the ideal gas behavior. It is the measure of deviation. Compressibility factor is the measure of deviation from an ideal gas behavior. Measure of deviation from an ideal gas behavior. If Z is equal to 1, then it will be an ideal gas. For an ideal gas, Z compressibility factor is equal to 1. If Z is not equal to 1, then it is non-ideal gas. Are you getting it? Z is equal to 1 is ideal gas. Z is not equal to 1 is non-ideal gas. In the neighborhood of critical point, critical pressure and critical temperature, the gas does not behave as an ideal gas. So how to find out Z? Z is equal to pressure into specific volume upon R into T. Or we can write pressure into specific volume into molecular weight upon R bar into T. If you put the values, you will get the answer. Pressure is, put all the parameter in their SI unit, 18.56 into 10 to the power 6 because it is in megapascal. Specific volume 6.4 into 10 to the power minus 3 meter cube divided by specific volume is volume per unit mass. I could have written like this. Pressure into volume per unit mass. So volume is this, molecular weight is 16 by 1000 kilogram per mole. 16 by 1000. And R bar is 8.314 joule per mole Kelvin into temperature is given in degree Celsius 13. So it will be 273 plus 13 into what is the mass? Mass is 1. This will give you the answer for Z. Can you solve it? What will be the value of Z? This 10 to the power 6, if you simplify this 10 to the power 6 will get cancelled out with this 10 to the power minus 3 upon 10 to the power 3. Isn't it? So it will be 18.56 into 6.4 into 16 divided by 8.314 into what is this? 273 plus 13? 283. 286. That is the value of Z. Do let me know what is the value of Z. 18.56. It is all about the units and dimensions. 6.4 into 16 divided by 8.314 divided by 286. 0.799. Or it is around 0.8. The answer will be 0.8. Compressibility factor will be in the neighborhood of critical point. What is the critical point? The temperature and pressure at which the liquid and vapor phase of a pure substance become identical. So in the neighborhood of critical point, the gas deviates from the ideal gas behavior. The next one, common data question 7 and 8. An insulated, it is insulated. An insulated piston cylinder assembly. This is the piston and this is the cylinder. Having a paddle wheel. This is the paddle wheel. Having a paddle wheel as shown in the figure contains air and R specific gas constant is 287 joule per kg Kelvin. Specific heat at constant volume is given of mass 4 kg. Mass of the air is 4 kg. Both piston and paddle wheel can be considered as insulated and massless. Piston as well as the paddle wheel are also insulated. It means Q is equal to 0. Temperature and pressure of air inside the cylinder are T1 is equal to 300 Kelvin and P1 is equal to 100 kilopascal respectively. Ambient pressure, that is P naught, is 100 kilopascal. Outside pressure is 100 kilopascal, same as the pressure inside the cylinder. Now the question is, if the piston is locked in the fixed position, what is the meaning of that? If the piston is locked in the fixed position, it means volume will be constant or change in volume will be 0. Change in volume will be 0. And the paddle wheel delivers 75 kilojoule of work. Due to rotation of the paddle wheel, there is a 75 kilojoule of work is produced. That is the work done on the system. On the system, the work is done by the paddle wheel on the system. Final air temperature is, what is the final air temperature? So if we use the first law for a closed system or energy conservation equation for the closed system, Q is equal to delta U plus W, total work done. Q is equal to 0. Q is equal to change in internal energy plus external work which is done by the paddle wheel plus P delta V. Q is equal to 0 because the piston is locked in the fixed position. This will also be 0. So we can say delta U is equal to minus W external, that is minus external work is done on the system, that is minus 75 into 10 to the power 3 joule. What is delta U? That is M into CV into T2 minus T1 is equal to 75 into 10 to the power 3. Mass of the gas is 4 kg. CV is given as 718. T2 is unknown, minus initial temperature of the gas or of air inside the cylinder is 300 Kelvin. 300 is equal to 75 into 10 to the power 3. Can you find out the value of T2 from here? Can you solve for T2? So those who have joined me late, please do like and share this session. What is the answer? What will be the answer? Are you getting 326.1? Are you guys getting it 326.1 or not? 75,000 divided by 4, then divide by 718 plus 300. 326.1 Kelvin, right? Now, the second part of the question is, if the piston is free to slide without any friction, it means if the piston is free to slide, pressure is constant. Pressure will be constant. It will be constant pressure process. When the pedal wheel delivers 75 kilojoule of work, the pedal wheel is still delivering 75 kilojoule of work. What is the final temperature? So Q is equal to delta U plus W. Q is equal to delta U plus P into delta V. Isn't it? Or can we write Q is equal to delta U plus W external? Delta U plus P delta V plus W external. Or can you write, because P is constant here, so can we write delta into PV plus W external? Or can you write delta into U plus PV plus W external? And what is delta U plus PV is H. So delta H plus W external is equal to Q. That is the expression for constant pressure. Q is equal to 0 because it is thermally insulated. So delta H is equal to minus W external this time. Minus what is W external? That is minus 75 into 10 to the power 3. And what is delta H? M into Cp into delta T. It will be Cp this time. And can you find out Cp? Cp is equal to R plus Cv. Cp minus Cv is equal to R. Cp is equal to R plus Cv. So it will be R is equal to 718. Sorry, R will be equal to 287 and Cv is 718. 287 plus 718. 287 plus 718. How much is that? 1005. So it will be 4 into 1005 T2 minus 300 is equal to 75 into 10 to the power 3 this time. Can you find out the value of T2 from here? Solve for T2. How much is the answer? Are you getting again option D? 318.7. Isn't it? Please do let me know, everyone. Are you getting option D or not? So this is the first law of thermodynamics. Now let us move to some questions from the application of thermodynamics. We are also running post-gate guidance sessions on our Byjus exam prep app, where we give you an insight about the expected cutoff for 2024 based on the previous year's cutoffs for various IITs, NITs and other PSUs. So do not miss these sessions, which will help you to decide the right career path as per your rank, as per your score in the GATE examination. The next one, question number 9. Question number 9 says, a Carnot refrigerator. What is a Carnot refrigerator? It is a reversible refrigerator. It is reversible. Operating between -1 degree Celsius and 33 degrees Celsius. This is 33 degrees Celsius. This is a refrigerator and this is -1 degree Celsius. Heat is taken, this is the storage space and heat is rejected to the high temperature reservoir and there is some work input. Has a cooling capacity of 1.6 kilowatt. 1.6 kilowatt. This is the cooling capacity of the refrigerator. The power consumed by the refrigerator is W is how much? So if we talk about COP for the refrigerator, that is the desired effect Q2 upon W. This expression is applicable for reversible as well as irreversible, but that can be written as T2 upon T1 minus T2. This expression will be only for reversible. So if we equate these two, then we can say from these two relation, Q2 is 1.6 kilowatt, 1.6 upon W is equal to what is T2? This is T2, this is T1. T2 is equal to 273 minus 1, that is 272 upon T1 minus T2. 33 minus 1, that is 34. So W can be calculated from here. 1.6 into 34 divided by 272 will be the answer. 0.2 kilowatt. Because the options are in watt, do not commit these mistakes. Or in kilowatt it is 1.8. Option D is in kilowatt, that is 1.8. Rest of the options are in watt. So 0.2 kilowatt is nothing but 200 watt. 200 watt, right? So option C will be the correct answer for question number 9. The next question, question number 10. Read the next one and try to solve. Atmospheric air having specific gas constant or is 287, gamma for air is 1.4 at 1 bar, that is the pressure P1, and 25 degrees Celsius, that is temperature T1, is compressed adiabatically. Adiabatic compression Q is equal to 0 to 2 bar. P2 is 2 bar and T2 is 105. Which one of the following statement is correct? The process is possible and irreversible, possible and reversible, impossible, possible and it is isentropic. Possible and reversible is isentropic. These two statements are same. Because these two statements are same, they cannot be true at the same time. They cannot be true at the same time. Isn't it? If it is MSQ, then only it can be possible that B and D are true together. So we can easily rule out. If it is MCQ, we can easily rule out B and D options. Now, how to find out whether the process is possible or impossible? Delta S for the universe. What is delta S for the universe? Which is delta S for the system plus delta S for the surrounding. If delta S for the universe is greater than 0, then the process is possible and irreversible. the process will be irreversible. If delta S is greater than 0, then the process is irreversible for the universe. If delta S universe is equal to 0, then the process will be reversible. And if it is coming out to be less than 0, then the process will be impossible. So we need to find out delta S for the universe, because the system is adiabatic, or the compression is adiabatic. It means Q is equal to 0. So can we write from TDS equation, can we write TDS is equal to DH minus VdP? Isn't it? Or can we write ds is equal to dh by t minus v by t into dp? V by t, v is equal to RT. From an ideal gas equation, PV is equal to RT. So V by T is equal to R by P. V by T is equal to R by P. So we can write ds is equal to Cp dt by T minus R by P into dP. If we integrate this, if we integrate from 1 to 2, if we integrate it from 1 to 2, 1 to 2, 1 to 2, 1 to 2, then we will get delta S for the system is equal to Cp ln of T2 by T1 minus R ln of P2 by P1. That is delta S for the system. What is delta S for the system? What is Cp? Cp is equal to 1005 ln of what is T2 by T1? 105 upon 25 for you. You need to convert it into Kelvin. 105 plus 273 upon 25 plus 273 minus R is equal to 287 ln of P2 by P1, 2 by 1. Can you solve it? The answer will be joule per kg Kelvin. It will give you joule per kg Kelvin. If you solve this, then delta S for the system will be plus 40 joule per kg Kelvin. And because it is thermally insulated or the process is adiabatic, so delta S for the surrounding will be equal to 0. Because Q is equal to 0. Delta S for the surrounding will be 0. And delta S for system plus surrounding will be plus 40. Because delta S universe is equal to plus 40 plus 0, that is 40 joule per kg Kelvin, which is positive. It means the process is possible but irreversible. The process will be possible but irreversible. Are you getting it? The process will be possible but irreversible. I hope this is clear. Question number 11. The next one. An engine reversibly receives 1200 joule of heat at 900 Kelvin. After rejecting the heat to the ambient at 300 Kelvin, it develops 600 joule of work. The irreversibility in joule is. What is irreversibility? That is T naught into delta S for the universe. That is irreversibility in joule. What is T naught? Ambient temperature is T naught. So there is an engine, this is Q1, and it is receiving 1200 joule at a temperature of 900 Kelvin, that is T1, and it is rejecting the heat at the ambient, which is T naught is equal to 300 Kelvin, and it is developing some work. It develops 600 joule of work. So Q2, from the first law of thermodynamics, we can say Q2 is equal to 600 joule, isn't it? From the first law of thermodynamics. Now this is our isolated system. So I is equal to T naught, which is given T naught into delta S for the system plus delta S for the surrounding. Because it is our isolated system, so the surrounding change in entropy for the surrounding will be 0. No heat is rejected to the surrounding, or we can say I is equal to T naught delta S1 plus delta S2. This is 1, this is 2. So I is equal to T naught. What is delta S1? What is the change in entropy for the reservoir 1? Because heat is rejected, so the entropy will decrease. So minus Q1 by T1 plus in the second reservoir heat is added Q2 upon at a temperature T2. So this will give you the answer in. Put the values, you will get the answer. If you will put the values, you will get the answer. So is equal to 300, then minus 1200 by 900 plus 600 by 300. This will give you the answer. What is the correct answer? Can you solve it? Are you getting 200? The answer to this one is 200 joule. Isn't it? Question number 12 and 13. Saturated water vapor enters an adiabatic turbine. Adiabatic turbine means Q is equal to 0 at 0.8 megapascal and leaves at 0.1 megapascal. The mass flow rate of water vapor is 25 kilojoule per second. Use the following data table to answer the question number 7 and 8. This is the data table. So the question is the quality of steam at the exit of the turbine after an isentropic expansion. Isentropic expansion is entropy remains constant. So if we draw TS curve, this is 1 to 2 isentropic expansion. This is isentropic expansion. So S1 is equal to S2 and point 1 is at the saturated vapor line, 0.8 megapascal, and point 2 is on the constant pressure line, that is 0.1 megapascal, like this. So if we say S1 is equal to S2, what is S1? Do you agree S1 is this? S1. So S1 is equal to S2 and S2 can be written as SF plus X2 SG minus SF at 0.1. So the question is to find out X2. So we can write 6.6628 is equal to SF 1.3026 plus X2, then SG minus SF 7.3594 minus 1.3026. The only unknown is X2. Can you solve for X2? Dryness fraction or quality of the steam at the exit of the turbine. If you do the calculation correctly, then your answer should be 0.88. Isn't it? Your answer should be 0.88. B, C will be the answer. The next part, if the steam leaves the turbine as saturated vapor, it means the steam is leaving the turbine like this 1 and this is 2. It is leaving the turbine as the saturated vapor only. It is leaving the turbine as saturated vapor. This is 0.8 megapascal and this is 0.1 megapascal. So what will be the power produced by the turbine? If you apply the first law of thermodynamics, Q is equal to delta H plus W, that is steady flow energy equation, because it is adiabatic. So delta H W is equal to minus H2 minus H1, isn't it? In kilowatt we want the answer. So W dot is equal to M dot H1 minus H2. And what is H1? H1 is equal to Hg at 0.8 megapascal. And what is H2? That is Hg at 0.1 megapascal. So work done is equal to, what is the mass flow rate that is given? 25 kg per second. 25 is the mass flow rate. Sorry, let me write here. W dot is equal to 25 into H1. This 2769.1 minus H2, this 2675.5. That will be in watt or kilojoule per kg, na? So that will be kilowatt. That will give you the answer for kilowatt. Your answer should be 2340. Are you getting? Work done. C will be the answer. And one more information before we end our session. For GATE 2025 or 2026 aspirants, we are running the paid courses where we give you the complete syllabus in an organized manner along with the recorded classes, study materials, quizzes and mock tests. If you are interested to be part of this paid courses, you can contact the counselor to have one-on-one discussion for the paid courses or in general your preparation journey or how to prepare for your examination. Our counselor will discuss in detail regarding your preparation. All right, let us move to second last question. Question number 14. A gas turbine power plant operates with air and adiabatic index is 1.4 between 1 bar and 20 bar. This is a gas turbine power plant is operating on Brayton cycle. How to draw TS curve for a Brayton cycle? TS 1 to 2 is isentropic compression. 1 to 2 is isentropic compression. 2 to 3 is constant pressure heat addition. 3 to 4 is isentropic expansion and 4 to 1 is constant pressure heat rejection. 1, 2, 3, 4. This will be how. This is QS. This is heat rejected QR. So it is operating between P1 is equal to 1 bar and P2 is equal to 20 bar. The maximum thermal efficiency for the corresponding air standard cycle is, what is the thermal efficiency for a Brayton cycle? 1 minus 1 upon Rp to the power gamma minus 1 by gamma. And what is the pressure ratio? P2 by P1. P2 by P1 is 20 by 1, that is 20. So if you put the value, the thermal efficiency is 1 minus 1 upon Rp, that is 20 to the power gamma minus 1, 0.4 upon 1.4. Into 100. If we want it to be in percentage, into 100 will give you the answer. Thermal efficiency. If it is reversible cycle, then the thermal efficiency will be maximum. The answer to this one is 57.5, isn't it? D will be the answer. And one more question, in an air standard diesel cycle, how to draw the diesel cycle on TS curve? 1 to 2 is again isentropic, 2 to 3 is constant pressure heat addition, 3 to 4 is again isentropic expansion, and 4 to 1 is constant volume heat rejection. Like this. This is how 1, 2, 3, 4. And if we draw PV diagram for this PV curve, 1 to 2 is isentropic, 1 to 2 is isentropic, like this, and 2 to 3 is constant pressure, 3 to 4 is again isentropic, and 4 to 1 is constant volume. This is constant volume, this is constant pressure. This is 1, 2, 3 and 4. Heat is added at constant pressure, heat is rejected at constant volume. Constant pressure lines are having less slope compared to constant volume lines on TS diagram. So this is the curve. Compression ratio is 14. What is compression ratio? R. R is equal to V1 by V2 is equal to 14. V1 by V2 is 14. At the beginning of compression of air, the temperature is 27, that is T1. At the beginning of compression, that is T1 is given as 27, and the pressure P1 is given as 1 bar. If the specific volume after heat addition is 2 times, after heat addition, that is V3, the specific volume after heat addition is 2 times the specific volume after compression. It means V3 is equal to twice of V2. That is also given. Heat added in kilojoule per kg of air at constant pressure is, we need to find out QS. What is QS? That is equal to mCp delta T. What is delta T? T3 minus T2. T3 minus T2, that is QS, mCp, T3 minus T2. Mass is 1 kg per kg. Cp is given as 1005, and now we are interested in T3 and T2. So because 2 to 3 is constant volume process, constant pressure process 2 to 3 is constant pressure. So it means V is directly proportional to T, or we can say so what is given is V3 by V2 is 2. V3 by V2 is equal to T3 by T2, that is given as 2. So T3 is equal to twice of T2, isn't it? So T3 is m into Cp, that is twice T2 minus T2. So that will be m into Cp, then into T2. Now how to find out T2? 1 to 2 is isentropic. So T2 by T1 is equal to V1 by V2 to the power gamma minus 1. So T2 is equal to T1. What is T1? T1 is given as 27, 273 plus 27, 300 Kelvin into V1 by V2 is 14 to the power gamma minus 1, that is 0.4. So T2 will come out to be 14 to the power 0.4 into 300 Kelvin. So it will be 862.13. T2 is equal to 862.13 Kelvin, isn't it? Put the value here. So QS is equal to 1 into 1005 into 862.13. That is in joule. The answer are in kilojoules, so we can multiply with 1.005. That will be in kilojoule. So 862.13 into 1.005 will give you the answer 866.44. Kilojoule will be the value of QS. 866.44. Kilojoule 866.44. D will be the correct answer for this question number 15. So that is all from my side. I hope you understood the concept, you enjoyed the concept. If you have anything to ask, please do let me know. Otherwise, do like and share this session, and see you in the next class. Till then, enjoy, take care, have a good day and a great career ahead. Thank you very much for joining in. Take care and Jai Hind.